Hi again, my name is Gene. I'm a new mentor for high school robotics team FRC 714 from Newark, New Jersey. We made this video series about how ridiculously easy it is to program FRC competition robots in Python. Much easier than in Java, if you ask me. If you are a mentor or a student from another team also looking to transition all students to Python, please just go ahead and use our examples and never look back. Everyone will thank you when they start looking for internships after graduation or in college. In the previous video, we saw how anyone can get some good practice with Python by playing online coding games and programming drones. But in this video, we need to program a real FRC robot. To be safe, we're gonna start with the smallest and safest possible FRC robot, the XRP. First of all, what is an XRP? If you ever played with a Romy, XRP is also a small FRC robot that's a little bit more advanced, and it is cheaper. For example, you can buy it from SparkFun for $94, and you can even get a discount if you're a school and you're paying many of them. So yeah, you just can add it to carts and get the chips, and you'll have it. You don't need anything else to a few batteries. It will come in a box like this. What you have to do is it will come in parts. You have to find this XRP assembly video, XRP assembly, this one, and you gotta watch it.
Hi there, Spark fans, Rob.
It's a 15-minute video. It's very easy to assemble. You literally do not need any tools whatsoever. And after you're done, it will look kind of like this. Has two wheels that spin. It has two wheels that are just kind of like balls. And batteries go here. You can see I can probably open it. There are batteries inside. In the front, there is a distance sensor and a little bit another sensor here for line following. And you can program it in exactly the same way as you program the big FRC robots. An important detail is before you can program it for anything that looks like FRC, you have to make one more step. You gotta get yourself a USB, micro USB cable like this. You'll have to plug it into your XRP robot, kind of like here behind the arm. There is a little bit of a connector to which you can plug it in, and then the other end goes into your computer, and you have to flash it with special software that will enable it to be programmed for using WPLib from FRC. I'm going to go ahead and plug it into my computer, and we'll go from there. So we need to upload the FRC, a special FRC image onto our little XRP robot. What we need to do is we just type in XRP FRC imaging into Google and see what we get. So this is the manual. It says to get started with the XRP, we need to have our hardware. We do have it here. Next step is we need to download the firmware by following this link. Click. So this is the XRP firmware for FRC. If I scroll down, this is the actual file, XRP WPLib firmware. I'm gonna click and download it. Here, it's downloaded. Perfect. Then we need to extract the contents. We did it. And now we're gonna take our USB cable and plug it into our computer. What we should see is that on our robot, the red LED light will come up. Robot is now powered. We see that it was found as a Pico disk. Now, what you will see on the robot is there's this little white button called boot cell. It's on the green module in here. I'm gonna hold it and I'm going to quickly press the reset button, which is here to the right of it. You will see it once you have it. And now we are ready to upload the firmware onto the board. What you will see is if you look at your computer, disk C, now we have another disk here called RPI RP2. What we can do is we can go to downloads where we downloaded the firmware and we can drag and drop the FRC firmware for this robot into that new disk, which will upload the firmware onto the. Now the robot is reconnected. And we can unplug the USB cable and run it on battery power. Okay, our robot is ready for a little test. We're gonna flip the switch to power it on. The red light in here should come up. And what we should be able to do is we should be able to find the Wi-Fi network of the robot in here in the list of Wi-Fi networks. I'm gonna turn it off, refresh the list, and hey, will we see XRP? Yes, XRP is here. Connect. We are connected. Let's see if we can go to the web interface of the robot. This is the address. Let's plug it in. Connected. Website. XRP something something. And this means we are ready to program this robot now. So today we're going to program this robot to obey the commands, the clicks, the sticks of this little green joystick. And I have put the link to the code, a ridiculously simple code, in the description of the video. It's here, it's on GitHub. Now we will need three things to work with code on GitHub and Python. We will need to install Python, we will need to install Git, and we will need to install PyCharm. Maybe you already have this, maybe you don't. Let's start. In order to download Python, I recommend that for this we use Python 3.9.13 download. We literally punch this into Google, Python 3.9.13 download. We go to the download page and we download. If you have a Mac, you download this or that. If you have Windows, you download this. If you have something else, you probably know what you need to download from here. Download, install, done. Next thing to install is Git. Again, download, Git. We go to the download Git website. If you have Windows, you click this. You have Mac, you click this. If you have Chromebook, or, if you actually have Chromebook, you don't need it. It will get installed automatically. If you have Linux, you know what to do. So download, click, install, everything will be done. Finally, we will need to download PyCharm if you don't have PyCharm. we punch in download PyCharm. It's a professional tool for making apps in Python. You go to this web page and you can download the professional version or you can download the free version. And for what we're going to do, free version is totally fine. You just scroll to the bottom of the page and it's called PyCharm Community Edition. You click on the download button, it will download, and then you can just click and install and everything will be well. I already have it, so I don't need to download. What I'm going to do is we're going to go back to this code that we need to download, this one. I'm going to open my PyCharm, which I already have, PyCharm Community Edition, and I'm going to click a button to get the code from GitHub. The button is Get from VCS. Here, I click Get from VCS, and then I need to put the URL, the link to the code on GitHub into this text box. And then I need to click clone button. Clone means download in case of GitHub. Clone. Downloading the code onto my computer. And there are a few things that we will need to set up before it can run. So this is super simple Python code to get XRP robot working. First, we gotta go and click into the lower right corner of this window, and we need to choose the version of Python. We click Add New Interpreter. We click Add Local Interpreter to create a virtual environment. And finally, we say we want a new virtual environment, and we pick the version of Python that we want. I want Python 3.9, which we just downloaded. I hit OK, and the virtual environment is going to be created for me. Next thing we're going to do after that is done is we'll need to install the requirements. If I go to project view in here, and inside I find the requirements file, I go into the requirements file, and I see these things highlighted in yellow. Package robot py is not installed. I can just click install all missing packages and they will get installed. But in case you don't want to click on those yellow highlighting, what you can do is you can go to terminal in here in the, let me show you. Terminal will open if you click this button, terminal button. And then into the terminal, you can say pip install -r requirements.txt. That's just one way you can do it. Then you hit enter and they will install. The other way, which I like because it's very simple, is you can just click the highlighted lines that say package robot py not installed. I'm gonna hit install all missing packages like this. Click yes, and installed. Package this, installing package that. It will install all the missing packages. All the missing packages are installed. We can proceed. First, I recommend clicking on the upper side of the window and picking the robot py sync configuration to possibly download from internet anything that it needs but was not downloaded yet. Hit run, which is this green button right next to the sync configuration. And it will try to synchronize, to download whatever was missing. I'm now connected to the XRP Wi-Fi network. And I'm starting this XRP program. And my joystick is connected to the computer. So because the joystick is connected, in this simulation GUI, a simulation graphical user interface, we see the Xbox controller pop up in here. I need to drag it and drop it here onto the list of joysticks. Now joystick number 0 will be this green Xbox controller. If I start pushing the buttons up and down, I see pushing the sticks. I see axis number 1, which apparently is the driving stick. Take values +1, -1. If I start pushing right and left, axis number 0 is changing between -1 and +1. And finally, if I switch it from disconnected state to the teleoperated state, I should be able to drive the robot by pushing on that stick. I push the stick forward and the robot is driving. I push it back and the robot is driving back. I push it to the side, it's turning. I push it to the other side, it's turning to the other side. Things seem to be working. One important detail is if you want this robot to work best, when you're powering it on, it has to be on a stationary surface and flat when you're flipping that switch. Because after you're flipping the switch, it will take 5 seconds to calibrate the gyroscope on a flat surface. Then it will drive really well. If you have done this well, you should be able to see something good when you run that robot. Here, the robot is started. We are connected to its Wi-Fi. And if you kind of expand this window a little bit downward to see what's on the smart dashboard, you will see the readings of several important sensors. One reading is the heading of the robot. It is now heading in the direction of 172 degrees. If I switch it to teleoperated, from disconnected to teleoperated in order to drive it, and I drag my Xbox controller to my joystick number 0 in here, I drag the Xbox controller to here, joystick number 0, and I look at the reading of the heading of the robot. If the robot is turning, the heading is changing. If it's turning right, the heading is getting closer to north, 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 0 is north. So when the robot is turning, the gyroscope is reporting different heading. And now finally, if the robot is driving north, I should be able to see the X and Y, which are the coordinates of the robot on the field. I should be able to see the X go up when the robot is driving north, and Y should almost not change. And when the robot is driving back, the X becomes negative. This is called odometry. What the robot is doing is it's counting how many wheel revolutions have happened to the right wheel and the left wheel, and which way the robot was heading. Based on this, it can recover where it is on the field, the X and the Y. In this case, this is in inches. Another thing that's pretty cool about XRP is it can sense how the distance to the nearest object on the front from this distance sensor in here. The distance is in meters, so the readings above 0.5 are not very reliable. But if it's approaching an obstacle in the front, for example, my hand, look what happens to the distance. The distance becomes smaller and smaller and smaller, and maybe when the distance is small, we can write the code for robot to no longer drive forward when the distance is too small. Now, when my hand moves away, the distance increases. Hand moves closer, the distance to the obstacle drops down. This one. The hand goes away further and further, and when there is a lot of distance in the front, it is not reliable. It's too far. The ultrasonic sensor cannot sense how many centimeters or how many meters exactly. Let's now go to the code and let's try to change the code in such a way that if the distance to the obstacle is less than 0.05, which is we're very close to the obstacle, we're not going to allow driving forward anymore. So I'm switching back to PyCharm and I'm hitting the stop button to stop the code from running. I'm going to the project view in here, and inside of the project view, I'm gonna find the robot.py, which is the program for this robot. Let's find a place where the joystick is created. Here, joystick is apparently joystick on port number 0. Joystick on channel number 0. And if we scroll down to how the joystick is used inside of robot periodic function, this is the function that will be called 50 times per second. Then what we're going to see is that literally we take the value of the left stick from the joystick, and this is going to be our forward speed. Positive forward speed means that the robot is going forward. And then we take the value of another stick, right left stick, and we say this is going to be our turn speed. And then we just say, hey drivetrain, please drive with those speeds. So let's go to this robot periodic function where we take the forward speed from the joystick and we feed it into drivetrain. And let's say this. If drivetrain distance to obstacle is less than 0.15, and forward speed wants to be positive, greater than 0, then we're going to set forward speed to 0, which is if we're too close to an obstacle, less than this much, and we still want to drive towards the obstacle, then don't allow driving towards the obstacle. Will the robot be able to stop before hitting the wall? Let's see. So let's pay attention to the distance sensor. Now the robot is pretty far away from the wall, and I'm going to start driving it towards the wall with my joystick. The distance is now 0.3, and the robot is still driving towards the wall. Now the distance is 0.11, which is less than 0.15, and no matter how I push the stick, the robot is refusing to drive closer to the wall, so it has avoided a collision. Can I drive it back? Yes, negative speeds are allowed, but can I drive it forward towards the wall? No, it's going to stop before hitting it. Success! Can you try it on yours? Let's see. Congratulations! Today we have downloaded everything that was needed to program a real competition robot in Python, and we have tried to implement a very simple collision avoidance program using a little XRP robot. And it was so simple, right? Please stay tuned, and in the next video we will try to do something that's a little bit more advanced. We're going to write a command-based robot code, which is the kind of style of programming your robots that is used by most of the teams which won the world finals in the last few years.